Hi folks, this is number 27 from page 555. So they want us to find the equation of a plane, and this plane passes through 5, negative 5, 5, and is perpendicular to the line of intersection between these two planes. Okay, so first and foremost, once we find this line of intersection, how's that going to help us determine the equation of the plane? Well, you got to figure you've got a plane, okay, and you've got a point on the plane, which we need, and it's going to be perpendicular to this line. Okay, so that means that the direction vector of this line will also be perpendicular to the plane. So this direction vector of the line is going to become my normal vector to the plane. Okay, so that's going to be our goal. First thing though is to determine the intersection of these two planes. Okay, now they specified, clearly they must be planes since I see x and y's and z, so these cannot represent just lines. So we can certainly solve this system of equations, but I actually think we can do this a little quicker, okay? Because the line of intersection, since it's an intersection, must be on both of these planes, okay? So if I take, a little representation here, so here's my two planes, okay? So my intersection is a line. This line is on both the planes, okay? But that means that if this line is on the plane, it must be perpendicular to the direction vector of that plane there. The normal vector to that plane. And this line is also going to have to be perpendicular to the normal vector of the second plane. Okay? Because any line, segment, vector on either of these planes has to be perpendicular to the normal vectors. And so when you think, I've got two vectors that are perpendicular to a third vector, it means they're connected by the cross product. So what I can do is just take the cross product of the two normal vectors, and that'll give me a vector in the direction of this line. Okay, and since all I'm looking for is a direction vector, I don't actually need a point on this line. I can do a little less work. Okay, so let's take the cross product of these normal vectors. So this is going to be, and be careful, remember there's the y value there, so 3, 0, negative 2, and the other one here will be 4, 3, and 0. Okay, and let's take the cross product. So what do we have? We have 0 minus negative 6, so we've got 6. Here we've got negative 8 minus 0, so just negative 8. And then here we have 9 minus 0 is just 9. Okay, so can't simplify this, so we'll use this as our, this becomes our direction vector for the line, but also our normal vector for the plane that we're looking for. Okay, so now that we have a normal vector and we have a point, we can just stick that into our general equation. So here, normal vector is 6 times the x component of our point, so 6 times 5 minus 8 times negative 5 plus 9 times 5 plus d is equal to 0, and so d is just equal to, so here we have 30 plus 40 is 70, plus 45 is 115, bring that to the other side, negative 115, and so our answer is just going to be 6x minus 8y plus 9z minus 115 equal to 0. Okay, so we see in this question here, just to do a quick recap, that we're able to save ourselves some time. So first of all, to realize that if this line that I'm determining or that I'm interested in is perpendicular to my plane, then the direction vector of the line can also act as a normal vector to my plane. Okay, where we really saved ourselves some time is realizing that because the line of intersection is on both planes, it means that the direction vector of that line must be perpendicular to both normals. Okay, and so that's why we're able to use the cross product to determine such a vector. Okay, that's it for this one.